Hi guys, and welcome back to Aisha's Academy. And I'm just honestly trying to go through as much this weekend, especially because I know it's May bank holiday. So let's get right into it. For this one, it is the foundation geometry paper. I've done the higher one already on the channel. All right, so okay, question one, it just literally shows the 3D shape and it's asking us the name of the shape. We can see that this is a cuboid. Because cuboid, remember, it has the rectangular faces. Okay, so then part B, it says write down the number of edges of this 3D shape. Remember, edges is the flat lines of the shape. So it's literally, these are your edges. Remember, the points are called your vertices and the flat lines are the edges. So we can see as 1, 2, 3, 4, 5, 6. Because remember that dotted line does count. 7, 8, 9, 10, 11, 12. Okay, so we can see that there are 12 edges. Okay, so moving on to question 2. So it's given us ABC is a straight line and it says work out the angle X. Well, all the angles on a straight line add up to 180 degrees. So if we know that one of the angles is 150, then to work out X, you would do 180 minus 150. That would give you an answer of 30 degrees. And your reason is literally because all angles on a straight line add up to 180 degrees. Okay, so it says the diagram below is wrong. Explain why. Okay, so in a circle, so all angles in a circle add up to 360. Well, we can see that we've got 280 here and we've got this box angle. And remember that box angle is known as a right angle, and a right angle is 90 degrees. So if we did 280 plus 90, we would get 370. And so the reason why this is wrong is because all the angles in a circle should add up to 360, not 370. So because all the angles in a circle should add up to 360, not 370 degrees. Okay, then this next question, it's basically given us a bunch of shapes and it wants us to name shape E. So shape E is over here. So shape E, where it's got this kind of shape where you've got two lines that are parallel, you've got a perpendicular height going on, and you've got a slanted line. We call this a trapezium. Okay, and then for part B, it goes on to say that two of the shapes are congruent. Write down the letters of these two shapes. So congruent means the same. So we need to find the two shapes that are the same. Well, let's have a look. We can see that A is also a trapezium, but A's trapezium doesn't really look like E's trapezium. Their lengths are slightly different. In the sense of, for instance, here, A's parallel lines, one of them is 6 boxes, and here it's 5 boxes, whereas E's, they're definitely bigger. One of them is 6, but then this one is definitely more than 5. So we know A and E can't be similar, and A isn't similar to anything else because there's no other trapezium, so we can cancel those twos as potential options. Then we're left with B, C, and D. Well, looking at B, no other triangle really looks like B because C and D both look like right angle triangles, but we're going to compare them after we cancel out B to see if they're really the same. So let's look at C. So it's got a length of 4 here, 4 boxes here, and it's got the diagonal line. And D also has 4 boxes here and 4 boxes here with the diagonal line. So we can happily say that triangles C and D are congruent, aka the same. Okay, moving on to the next question. So question 4 is basically saying that the length of a rectangle is twice as long as the width of a rectangle. And it says the area of the rectangle is 32 centimeters squared, and it wants us to draw this on a centimeter grid down below. So first of all, the equation for the area of a rectangle is length times width. So length times width would give us an answer of 32 centimeters squared in this example. However, it said that the length is twice as long as the width. So the length is equivalent to 2 of the widths. So we can substitute that into our formula. So rather than saying length times width, we can say 2 widths, because 2 widths is equivalent to the length, times the width is equal to 32. So now we're going to solve this algebraically. 2w times w would be 2w squared is equal to 32. Divide both sides by 2, you're left with w squared is equal to 16, and square root of 16 is equal to plus and minus 4. But because we're dealing with lengths, you can't really have a negative length, so it will just be the positive 4. So now we know that the width is 4. To work out what the length is, length times 4 is equal to 32. So then divide by 4 on both sides, and so your length would be equal to 8. Or another way of working it out is, if you know that the width is 4, substitute that here. So 2 times 4 also gives you 8. So now we know that the length is 8, the width is 4. So our width is 4, and the length is 8. That is not 8, that is 8. So yeah, that would be fine. So you could have literally just, as long as you draw the same dimensions, you could have started drawing your rectangle anywhere, but that is completely fine. So just to they know, I'm just saying that this is 8 centimeters, and you can put length if you want, just so they know, and then this is 4, but you don't have to. This is just me showing it for example's sake. Okay. Then question 5, it says on the diagram, draw the diameter of a circle. So we know the diameter of a circle goes from one end of the circumference, is a line, it's a straight line that goes from one end of the circumference to the other end of the circumference, but it needs to pass through the radius, which is the point in the middle. Not the radius, sorry, it needs to pass through the center, which is the point in the middle. So diameters must pass through the center. For instance, let's draw that meter. Hey, for instance, this is a diameter, so I'll just put diameter. Now, part B wants us to draw a segment of the circle. So the difference between the segment and the diameter is a segment also goes from one end of the circumference to the other. However, that line does not need to pass through the center. So obviously, I know in your exam you would just have one straight color as a pencil, but for the case of the example, I'm going to draw the segment in a different color. So for instance, like this. Okay, let's move on. And in this part of the question, it says shade the segment. So meaning that the segment that we drew, we are just going to shade it. So if I go back up, because I drew it in blue, I'm just going to shade it in blue. But ideally, yours would be in pencil, so it would not be blue. But yeah, just to show you that. Okay, rectangle, and it says it's the six-sided shape below is formed from 2 of these rectangles, and it wants us to work out the perimeter of the six-sided shape. So let's quickly label the dimensions. So in black, that was 4, 6, 4. That was 6, and then they've literally just done the same rectangle, but they've just rotated it 90 degrees. So 6, 4, 6, and the whole part, just to make it clear, that whole part is 6. This whole part is 4. Okay, So now it wants us to work out the perimeter. So remember, perimeter is all of the sides added together. So the two lengths in the middle, we're not exactly going to use them in our addition, but they may be useful. I'll give you that hint. So remember, perimeter, we're going to be focusing on all these lengths. So we have every other length. The only length that we don't have, though, is this gap here. And that is from the difference of your 6 and your 4, which is 2. That's why I was saying that we needed them. But now that we know that that's 2, we don't essentially need them anymore. So that is why we can rub them out. So yeah, we just need to add everything together. So then you're going to do 6 plus 4 plus 4 plus 2 plus 6 plus 6 and plus 4. So we should have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Yep. So then add them all together. So that's 10 plus 4, 14, 16, 22 plus 10, 32 centimeters. Remember, perimeter is total length, so it's not like area where it's squared. It's just 32 centimeters. Okay, we can write that down here. All right, so moving on. So then it's now saying work out the volume of the cuboid here in question 7. So volume of a cuboid is length times base times width, or length times base times height. Either way, it's just literally this length, I'm going to call that x, times this length, which is y, times this length, which is z. So you always go around from that view, and that always helps to work that out. So we know that our z that we've labelled is 10. So one of the values that we're multiplying is 10 times 15 times the height up here, which we call it 4. So you just multiply them all together. So if you put that into your calculator, you can work out manually. So that'll be 150 times 4, that's 600 centimeters cubed. So remember, volume is centimeters cubed. Okay, then we have this grid, and it says draw an enlargement of the shaded shape with a scale factor of 3. So remember, when it comes with enlargements, you always. So now, the thing is with this question, and I'll explain why it's 2 marks rather than 3. So with enlargement questions, you can either get 2 marks or 3 marks. It would be 3 marks in the case of where it involves enlarging from a center point. But notice that in this question, it doesn't say that from a particular point that we need to enlarge from. So you just need to draw enlarged in any of these spaces. They've given you plenty of space to draw that enlarged shape. And like I said, because they haven't given a center point, there's not a specific place where that shape needs to be present. So let's just count the number of squares in each side. So this is 2, this is 2. This is like diagonal by like 3. And then this is also diagonal by like 3. Okay, so because it's a scale factor by 3, we're going to multiply all these measurements by 3. So the 2 across here times 3 will be 6. Here it will be times 3 is 6. So we can draw those out first because they're quite nice. So then 3, 6. So I've drawn my 6 down and my 6 across. Then it was diagonal in like 3 by 1. So it would be diagonal 3. So that would go up. So if it's by 1 times that, it would be 3. It will be 9 by 3. So the by 3 would be here. So it would be somewhere along this line. And then if it's 9, so 1, 2, 3. Okay, so that's where that part is ended up. Then the last bit. So with enlargement or rotations or anything, once you've worked out part of it, if you can just see the pattern straight away, you can just connect the rest. So okay, and that would be that shape. Alright, and then question 9, it says a square has an area of 81 centimeters squared, and it wants us to find the perimeter of the square. So again, square, the area is length times width, and it's 81. The special bit about a square is that all the sides are the same. So the length and the width are the same. I'm just going to call them W times W. You could just call them length times length, either way. So that means W squared is equal to 81. W is equal to the square root of 81, which is 9. So all the sides are equal to 9. And remember, perimeter is when you add all the sides up together. So it's just going to be 9 plus 9 plus 9 plus 9, which would leave you with 36. Okay, and then it says the diagram shows a right angle triangle and a parallelogram. It says the area of the parallelogram, you know what I mean, is 5 times the area of the triangle, and it says the perpendicular height of the parallelogram is h, and it wants us to work out what h is. So area of P, I'm just calling it P for parallelogram, is 5 times the area of the triangle. So 5 times the area of T. And then it says the perpendicular height of the parallelogram is h. And then it wants us to find what h is. So we know the area of a triangle is half base times height for a right angle triangle. Well, for foundation, you don't need to know the half AB times C. So this is the only area of the triangle you need to be aware of. So then that's going to be half times 9 times 16. And putting that all into your calculator would leave you with an answer of 72 in your calculator. So now we know that the area of the parallelogram is 5 times 72. If you put that into your calculator, you should end up with 360 centimeters squared because we're dealing with area. So we know that the area of the parallelogram is 360 centimeters squared. So to work out the area of a parallelogram, it's usually your base or your width or whatever you call it, base times your perpendicular height, which is our h, is equal to 360. So because we know the base is 30, so 30 times h is equal to 360. So to work out what h is, divide both sides by 30. You would be left with h as 12 centimeters. And that is our perpendicular height. Okay, so the next question, if I just zoom out so you can see clearly, it says rotate the shape A 90 degrees clockwise about the center. You see here they're mentioning the center. So center O is literally here. And if it says 90 degrees clockwise, the best way I always remember when it comes to rotations is notice how on a graph you've got 4 different quadrants. We know that if you go around something clockwise, i.e. in a circular motion, so it adds up to 300 degrees. Now, when you're rotating around the center, it's nice to think if you split them all up as 90, 90, 90, 90. So for instance, if you're rotating 90 degrees clockwise, you'll know your shape will be in this quadrant. Let's say if you started off from shape A and you're rotating 180 degrees clockwise, 90 plus 90 is 180 degrees. And clockwise is that way, so your shape would end up here. Or let's say if it was 90 degrees anti-clockwise, your shape would end up here. So sometimes knowing that really does help to know where the shape will end up, because I know sometimes that does confuse students at times. So now moving on with this question, we know that the shape will end up in this box, but we need to know exactly where it's going to be because it's about a center. So what we need to do is we need to draw a line from the center to at least one of the points on the shape. Now, because we know it's 90 degrees, 90 degrees, so if you were to now go clockwise 90 degrees, end up there. Yeah, it would end up there because remember 90 degrees, it has a 90 degrees angle. So then that point would end up there. This point is 3 there. So that would end up here. This point is 4 there. That comes up there. I know it looks very messy as you're going along doing it, but hopefully when you're done, then you can always rub out the lines. It's just to help you to know where it would be. That's 4 diagonal, so that would end up there. So then connect everything together, and then we can rub all the lines out. And you'd be left with this new shape that has been rotated 90 degrees. So my biggest advice with rotation is sometimes using the line technique, practice doing that. Because it's only with practice that you understand patterns of how to rotate it. Yeah, that's okay. So having a look at part B, it's now saying it's now given us the type of transformation, and it wants to describe the transformation from triangle B on C. So we can see that it kind of looks reflected. I wouldn't say an enlargement because they're both the same shape. It hasn't been rotated because they're both pretty much the same. The only thing that I would just simply say is that it has been reflected, but we need to know what line it's being reflected by. So, as we can see, the mirror line is our y-axis. So you could say anything along the lines of it's being reflected by the y-axis, or it's being reflected by the line x equals 0, because that's also known as the y-axis. So that's fine. The y-axis. So you get a mark for saying reflection and a mark for saying which line. Okay. And then on to question 11. It's now saying that the diagram shows a square ABDE and an equilateral triangle BCD. So it says it wants us to work out the size of angle EBC, which it has labeled already. So let's look at what we have. So because we know that ABDE is a square, and we know that all squares have right angles, so they're all at that point 90 degrees. Okay, then now that we know that we've got a line going diagonally across through with the E to the B line, we would also know because it's been split in half equally, half of 90 is 45. So that would be 45 degrees. So another key thing is we also have an equilateral triangle, meaning all the sides are the same. And in an equilateral triangle, all the angles are, so in a triangle, it adds up to 180 degrees, but if it's equilateral, divide that by 3, so it's equally split. And so that means each angle is 60 degrees. So now we know the angles for the triangle and the angles from the square being split in half is going to be the 45 degrees plus the 60, which leaves you with an answer of 105 degrees. Then moving on to question 12. So question 12 shows a prism with a cross section of the shape in the shape of a trapezium. And it says on the grid below, it wants to draw the front elevation and the side elevation. So let's look at the front elevation. So front elevation is from this perspective. So it would just literally be focusing on this part. And then here it's now giving us a scale. So it says 2 centimeters is equal to 1 meter. So here if we want to convert the meters into centimeters, times by 2. To go from 1 to 2 times by 2. So times everything by 2, and that would be the equivalent in centimeters. Okay, so it will be 4 centimeters, 4 centimeters, and 1 centimeter. So if we draw that on our grid, I'm just going to zoom out so you can see the shape as well. So front evaluation, 4 boxes, and then for side evaluation, it's just going to be this rectangular part plus the square bit there. So again, times everything by 2, so you know the length. That'll be 2 centimeters. That'll be 1 centimeter, and this will be 5 centimeters. Then what we need to do is draw that on the graph. So because this one is slightly different to the front direct dimension, it's like from the side view, it would kind of look like as if you have two rectangles that have been split up. So let's draw the bottom rectangle first. So it was 1 by 2 by 1. Oh, that's 3. By 1. And then it had the tall part as well. So now the key thing to note here is that for this length here, the 2.5 centimeters, essentially we're not going to be drawing that down, because if you're looking at that side on, you're not gonna really gonna see a slant. It's gonna look like a flat plane. So we're gonna focus on this 2 meters here. So I'm gonna zoom into the shape again. I'm gonna focus on that 2 meters again, because that's the main height of all of that. So remember when we times it by 2, that was 4 centimeters. So bear in mind, 1 centimeter has been taken up here. So the rest of that part would be 3 centimeters. So now drawing it on, we need to draw 3 centimeters up. And that is the final answer for that one. Then moving on to question 13, it says each exterior angle of a regular polygon is 15 degrees, and it wants us to work out the number of sides. So based on your angle of polygon equations, we know the exterior angle is 360 divided by the number of sides. So we know the exterior angle is 15, so it'll be 15 is equal to 360 divided by n, which I'm calling n number of sides. So to work out number of sides, rearrange this. So it'll be 360 divided by 15 is equal to n. And in your calculator, that should leave you with an answer of 24. So this shape has 24 sides. Okay. Now, looking at triangle BEG, so question 14, so I'm just going to draw there. Okay, so it's now showing, oh, this came up in the higher geometry as well. So again, I'll go through it again. It wants us to work out the size of angle X, and it wants us to give reasons for our working out. Okay, so first things first is, the first reason is because all angles, so I'm going to zoom out a bit, all angles on a straight line add up to 180 degrees. So then 180, so to work out this angle here, 180 minus 110 minus 25 would leave us with an answer of 45 degrees. So that angle is 45 degrees. And then to now work out based on your knowledge of different angle rules, so different angles from parallel lines. So then alternate angles are the same. Alternate angles are your Z angles, but in an exam, do not put Z angles. I'm just putting the Z angles in the bracket so you understand, are the same. So then that means that that angle here is the same as this angle here. So remember, that big angle is the 45 plus the 25. So 45 plus 25 is equal to 70. So that would also be 70 degrees. And then again, angles on a straight line add up to 180. So then that would help you to work out what this angle is. So then 180 minus 70 minus 35 would leave you with an answer of 105, 75 degrees. So now we know that that's 75 degrees. To work out what x is, all angles in a triangle adds up to 180 degrees. And so 180 minus the 75 in the triangle minus the 45 in the triangle would leave you with an answer of 60 degrees. So we know that x is 60 degrees. And then on to question 15. So question 15 then asks, so it says work out 2a plus b. So in order to work this out, we are going to multiply the vector of a by 2. That means you have to multiply both the top and the bottom numbers in the vector by 2. So that would leave you with 10 over 4. And then because we're now adding them together, so that would be add to what b is, which is minus 1, 7. And then remember with vectors, you have to add the top numbers together, add the bottom numbers together. So that'll be 10 plus minus 1 and 4 plus 7. So we know if you have a positive and a negative next to each other, it ends up being a negative. So that would be 10 minus 1, which is 9, and then 4 plus 7, which is 11. And then moving on to question 16. So you have to use your ruler and a compass to construct the lines. With this question, I know I can't really do this on the screen, but I'm just going to show you a rough guesstimate of what it would look like. So using your compass, your sharp point of your compass would be on P, right? So your sharp point of your compass would be on point P. So then your pencil part, you need to end up drawing so put your pencil here, oh, or here. So just anywhere below the line of CD. Then you now want to draw an arc. So you draw kind of like an arc there. Then you're going to do the same thing on the other side. So then just rotate your compass round. Again, start with the line below, with the pencil below the arc, and then you're going to draw an arc. So then put points of these arcs. So let's just call this A and let's call this B. So then on point A now, you've now put the sharp point of your compass there. And now your pencil should be somewhere down here. So again, draw an arc from there. Then move your compass to now point B, the sharp part, and then draw an arc from there. And let's just say where it crosses over, we'll call it X. So then that point in the middle where it's now crossed over and through P, if you just draw a straight line, this is where your ruler comes into it to draw the perpendicular line. You don't have to start all the way up there. I'm just drawing it for accuracy's sake because I don't have a ruler. So yeah, just drawing it up from P to where it crosses, that is your perpendicular line. So the main thing here is using your compass. Then your ruler is just to draw the perpendicular line. Then we have a right angle triangle. We've got an angle other than the right angle, and we have a length. So we're thinking of SOHCAHTOA. So let's label it. So then the line opposite the right angle is H. The line, which is our hypotenuse. The line that involves the right angle and the other angle is the adjacent, because adjacent means next to, so it's next to both angles. And then O are opposite because it's opposite the other angle. So then we are trying to work out the length AB, which is our opposite, and then we've been given our H. So we're looking for the one that involves both O and H, which is so. So it's going to be sine 38 is equal to, so it's always O over H, so it's always over that other letter, so it'll be O over 16, and then rearrange it, so 16 times sine 38 would give us the answer for O. So putting that into our calculator would leave us with an answer of, to 2 decimal places, it would be 9.85 centimeters. Okay, and then last question on the geometry foundation calculator paper questions. So it's now given us a right angle triangle and a quarter of a circle. It's given us that the right angle triangle ABC has an angle ABC, which is 90 degrees, and it says the quarter circle has a center C and a radius CB. So it wants us to work out the area of the quarter of the circle. So it says give your answer to the correct 3 significant figures. So in order for us to do that, we can see that from this, the line CB is the radius. So if we work out the radius of the circle, that would help us to work out the area of the quarter, because we know that the equation for the area of a circle is pi r squared. Pi is the same, but by working out our radius, we can be able to work out the area of the whole circle, then divide it by 4, to work out the area of a quarter of a circle. So to work out our radius, we have a right angle triangle. So we have two of the lengths and we don't know one other length. The only angle is the right angle. So we're thinking of Pythagoras. And Pythagoras is a squared plus b squared is equal to c squared. So let's label our a, b, and c. C is always the line that's opposite the right angle, and a and b, it doesn't matter where they are. So we can now rewrite this as 6 squared plus r squared, because that's our radius, is equal to 9 squared. So 36 plus r squared is equal to 81. Rearrange this, so r squared is equal to 81 minus 36. And if we put that into our calculator, that should leave us with an answer of 45. So now we know that r squared is 45. I'm not going to square root it to work out what r is. Why? Because already in my formula for the area of the circle, it says pi r squared. So if I already know what r squared is, rather than me now square root that and give me a long decimal place and then re-square it again, I'm just going to leave it as 45. So then pi times 45 is equal to the area of the circle, so it's 45 pi. Then to work out the area of the quarter of the circle, you're going to put into your calculator 45 times pi divided by 4. And that is going to give you the area of the quarter of the circle. So 45 times pi, and then divide by 4 to 3 significant figures, you would end up with an answer of 35.3 centimeters squared, because you're dealing with area. And that's the end of this paper. I hope that was useful, guys. Thanks for watching.